dear students of class 12. Today we will be starting with a new chapter, that is biomolecules. And under biomolecules, today we will be discussing about carbohydrates. Carbohydrates are those compounds which have polyhydroxyaldehyde or ketones. Okay, see, definition is written here: polyhydroxyaldehydes or polyhydroxyketone. Poly means you have many OH groups in that particular compound, polyhydroxy as well as aldehyde. Okay, so in a single compound you have many hydroxy group as well as aldehyde group. For example, glucose. Now other categories of compound also come under carbohydrate, that is polyhydroxy, many OH groups in the same molecule where we have ketonic group also. We will be discussing that with the structure in detail. First, focus on the definition. So carbohydrates are those compounds which have polyhydroxyaldehyde or polyhydroxyketonic group. Okay? Or there are also molecules, large molecules, polymeric forms, polymers, okay, which when hydrolyzed, when treated with water, now they yield what? They yield polyhydroxyaldehyde or ketones. So this is the basic definition. For example, let's take the example of glucose. The formula for glucose is C6H12O6. Now this is one of the carbohydrate here. Okay, so this is common to you, C6H12O6. Now with this formula, we can have two different compounds. So let me write this for the structure of this particular molecular formula. So here, how many carbons are there? 6. So 1, 2, 3, 4, 5, 6. So I have written 6 carbons starting from 1, 2, 3, 4, 5, 6. So please focus on how I write this structure. Okay. So here I'll give you some logic how to remember how to write this structure from the molecular formula. So here you have to understand that if this molecular formula you are writing the structure for glucose, then it contains aldehyde group, that is CHO. So the first carbon contains aldehyde group. Now look at how I write the structure. Okay, so here we will be starting the OH. We are going to write the OH group first. So we will be starting the OH group from this side. OH, second carbon, third, fourth, fifth, and here we have CH2OH. Now this side you have hydrogen. Wherever you have OH, the other side you have hydrogen. And here the valency of carbon is fulfilled on the sixth carbon. Now you generally see a pattern here. The OH group follows this pattern. Can you see that? It is giving you a shape of what? Z. Therefore, this is how you better understand it, how these OH groups are arranged in glucose. So this is the structure of glucose. So this is the open chain structure of glucose. And here you please understand this. The first carbon contains aldehyde group. Okay? Therefore, it is also known as what? Aldohexose. Aldohexose. Hex means 6 carbon. Aldo means aldehyde group. Now with the same molecular formula, you can have another structure where it is also a carbohydrate. It is also a carbohydrate, but it has a ketonic group. Please look at this structure now. So first carbon, 2, 3, 4, 5, 6. So this is CH2OH. Okay, as in case of glucose. Okay. Now here, in this case, you have a ketonic group at carbon number 2. Please remember, this is carbon number 1, 2, 3, 4, 5, and 6. With this molecular formula, I am writing the structure, the other structure. So here you have C double bond O. Now here the same pattern will be followed beyond this 3. 1, 3, 4, 5, 6. The same pattern will be followed here also. These two compounds differs in the structure of, in the arrangement of this hydrogen OH group at carbon number 1 and carbon number 2. Here you have carbon number 1, carbon number 2. You can see clearly that these two differ in the arrangement of atoms around carbon number 1 and carbon number 2. The rest is same. Here you have 1, 2. Here OH is this side. Here OH, OH. Now you saw here you have a ketonic group. Ketonic group, and this is also one of the carbohydrate. And the name of this particular compound is fructose. Fructose. So these two structures you have to learn them properly because this will come in your next topic also. Okay, we'll be discussing them in next topic also. Here I have shown you the example why these carbohydrates are known as polyhydroxyaldehyde. This is polyhydroxyaldehyde. Why? Because you have 1, 2, 3, 4, 5, so many OH groups. That is polyhydroxy. And why aldehyde? Because this glucose contains aldehyde group, that is CHO. Therefore, this is one of the carbohydrate. Glucose is one of the carbohydrate. Similarly, here in this compound, here we have what? Again, we have so many OH groups. So many OH groups. Therefore, it is polyhydroxy. And why ketone? Why ketone? Because this particular compound contains ketonic group at carbon number 2. And therefore, this is also carbohydrate. And this is the structure of fructose. Hope this is clear. Now let's move on to the next topic. I urge you to remember this pattern so that you won't be confused on which side you have to put H and OH. Okay? Z. Follow the pattern. First carbon contains aldehyde group, and from the second carbon it follows the pattern Z. Please follow this. Z for glucose. Don't forget. Now we will be discussing about classification of carbohydrates. Okay. Now, based on how many these simple molecules they yield on hydrolysis, they can be again classified. So the next topic is classification on the basis of hydrolysis. So classification. Let me use the other chalk. So classification on the basis of hydrolysis. Okay, so hydrolysis means whenever you treat the given carbohydrate with water in certain acidic medium, how many more simple molecules it can yield. Based on that, again, it can be further classified. And the first one is monosaccharide. Monosaccharide. So the name itself suggests mono means these are those carbohydrates which on hydrolysis do not decompose further. Okay? So now it is the minimum unit in a way to say it. So it is the simplest form. Okay? So if you treat this monosaccharides with water, upon hydrolysis, they do not decompose further. For example, glucose. Glucose is an example. Similarly, we have discussed about fructose. Fructose, these are those carbohydrates which do not decompose further on hydrolysis. Therefore, they are known as what? Monosaccharide. Now, the second one is oligosaccharide. Oligosaccharides. Now, these oligosaccharides are those compounds which upon hydrolysis, please remember, which upon hydrolysis yields those compounds, a definite number of compounds, okay, which contains 2 to 10 monosaccharides. Now these oligosaccharides are those compounds which upon hydrolysis yields how many monosaccharides? They yield monosaccharides between 2 to 10. These carbohydrates are known as what? Oligosaccharide. Now based on the numbers, it can again be classified further. These oligosaccharides can be again further classified. So under oligosaccharide, now we are just discussing about classification under oligosaccharide. Okay, please focus. Now the first one is disaccharide. So the name itself suggests disaccharides. Disaccharides. What does di mean? Di means two. So those oligosaccharides which upon hydrolysis yields two molecules or monosaccharides. Two monosaccharides are known as what? Disaccharides. For example, we have sucrose, maltose, lactose, etc. So example, these two means these disaccharides upon hydrolysis yields two monosaccharide. Okay, therefore they are known as what? Disaccharide. Example is sucrose, maltose, etc. Now similarly, now if they yield this oligosaccharide, if they yield 3 monosaccharide, then obviously they are known as what? Trisaccharides. So trisaccharides. Tri means 3. Upon hydrolysis, they are going to yield how many simple monosaccharides? 3. Okay? And example is what? Example is raffinose. Now this raffinose upon hydrolysis will yield 3 molecules. For example, if you hydrolyze this raffinose with water in acidic medium, it is going to give you 1 molecule of glucose, 1 molecule of fructose, and 1 molecule of galactose. So 3 molecules it is yielding upon hydrolysis, therefore it is known as what? Trisaccharides. Okay, please don't forget. And the formula of this one is C18H32O16. So the formula of raffinose is what? C18H32 and O16. Now this upon hydrolysis, okay, let me write it here. As I told you, this upon hydrolysis, you are treating with water in acidic medium. It is going to give you 1 molecule of glucose. Let me write the short form: glucose plus 1 molecule of fructose plus 1 molecule of galactose. Okay, this is the short form I have written. So you can check it in your book, the complete name: glucose, fructose, and galactose. So this will trisaccharide. Now, if you have those carbohydrates which can give you 4 monosaccharides, then that obviously the name of that particular oligosaccharide would be tetrasaccharide. So the third one under oligosaccharide is what? Tetrasaccharides. It is what? Tetrasaccharides. Tetrasaccharides. So upon hydrolysis, they are going to yield how many molecules? How many molecules? Simple molecules. That is monosaccharide. 4 monosaccharides. Okay? Monosaccharides. So 4. The name itself says tetra means 4. Okay? And the example of this particular tetrasaccharide is what? Starchy rose. Example is what? Starchy okay? So example, now this starchy rose upon hydrolysis will give you 1 molecule of glucose, 1 molecule of fructose, and 2 molecule of what? 2 molecule of galactose. In total it will be 1 plus 1 plus 2 is 4. Therefore it is known as what? Tetrasaccharide. Okay, hope this is clear. Now, so we have discussed monosaccharide, oligosaccharide. Under oligosaccharide we have disaccharide, trisaccharide, and tetrasaccharide. Now, the third category. The first one was monosaccharide, oligosaccharide. Now, the third one is polysaccharide. Hope you have noted down this one. The third one is what? The third one is the first one was monosaccharide, the second oligosaccharide, the third one is polysaccharide. Now the name itself suggests here, see, those carbohydrates which upon hydrolysis yields many number of monosaccharides or simple molecules are known as what? Polysaccharides. And here they are going to yield 100 to 300. Here, see, here this 100 to 300, okay? Here, this polysaccharides are those compounds which have the general formula C6H10 O5 whole N, and this N lies between 100 and 300. That means so many number. Therefore, so many number of monosaccharides. Therefore, it is known as what? Polysaccharides. C6H10 O5. Okay. An example is what? Example of polysaccharides are starch, cellulose, etc. These are example polysaccharides. This is general formula, and here the value of N lies between 100, more than 100, and less than 300. So such a large number of molecules of monosaccharide. Therefore, it is known as what? Polysaccharide.